All right, learner. So are you ready to really get into Ethereum design patterns? They might sound kind of boring, like something out of a textbook, but trust me, these are way cooler and definitely more useful than you'd think.
Yeah, they're really important.
We're diving deep into advanced topics and the road ahead, that last chapter you marked up, and we're going deep to unearthing the kind of insights that I think most people would probably just skim over.
Exactly. It's about going beyond, just having heard of Ethereum to really understanding the tools and concepts that are shaping the future.
Okay, so when I first saw design patterns, I'll be honest, my eyes glazed over a bit. But then I started thinking about it like those cooking shows, where they break down how to make classic French sauces.
Right.
So are these patterns kind of like that? Like the building blocks of Ethereum development or something? Like a secret sauce?
That is a great analogy. Yeah, think of design patterns as pre-tested solutions to common problems that come up when you're coding, or like blueprints developers can use to save time and avoid having to reinvent the wheel on every project. You've got your structural patterns, which are about how different parts of your code work together, like the architecture of it all. Then you've got creational patterns, which are about making new objects efficiently, and behavioral patterns to help the different parts of your code communicate.
Got it. So instead of starting from scratch every time, they can pull from these tried and true patterns.
Oh,
smart. The chapter goes into 5 key patterns, and that first one, access restriction, sounds like something you really want to get right, especially after reading about that parity library vulnerability. $300 million lost.
Whoa!
I know, right? That's enough to make anyone sweat.
Yeah, it's a very good example of what can go wrong if you don't implement access control correctly. And it shows how important this is, even though transparency is a core part of blockchain. Anyone can see the code of a contract. You can still control who has the power to actually change it.
So it's like having a security system on your code. You can't stop people from looking at your house, but you can control who has the key.
Exactly. Function modifiers, they're like those digital bouncers at a club, deciding which addresses have permission to make changes.
Okay, so access restriction is about controlling who can change the rules of the game. But what about the game pieces themselves? That's where token systems come in, right? And we've talked about ERC-20 before, but this chapter says it's not actually a technology. That kind of threw me.
It's a common misunderstanding. ERC-20 is more like a blueprint, if you will, for how tokens should function on the Ethereum network.
Okay.
It's like a universal language, making sure that all these different tokens can interact with each other.
Right, like a universal adapter for your crypto wallet. And this compatibility is what makes it possible for people to trade those tokens on exchanges and use them across different apps. So on to this factory pattern. Sounds a little industrial.
Think of it as a cookie cutter. But instead of stamping out shapes in dough, a factory pattern churns out multiple smart contracts from just one template.
So it's like, instead of coding each one from scratch, you're mass producing them, right? But with custom variations.
Yeah.
Like minting a series of NFTs. Each one unique, but they're all built on that same basic framework. That's cool. What's next? Registries. That one stood out to me because it mentioned human readable addresses, and I'm all about making this tech less scary for the average person.
Oh yeah, for sure. Those long strings of letters and numbers we use for Ethereum addresses, total headache.
I know.
Registries are like a phone book for the blockchain. They let us use regular names that people can actually remember and manage to stand in for those crazy addresses.
Yeah. That's huge, right?
Yeah.
No more copying and pasting those endless addresses. It's like the difference between remembering someone's Instagram handle versus their actual phone number. Way more user-friendly.
Right.
Okay, last pattern on the list, voting systems. And this one sounds like a real doozy.
Yeah, it's definitely one of the trickiest to get, right? Which makes sense. I mean, creating a secure, truly decentralized voting system.
Yeah.
That's like the holy grail for a lot of blockchain folks. But it's not as easy as it sounds. We can't just record votes on a digital ledger and call it a day.
Right.
You got to think about voter ID, making sure it's anonymous, but also preventing fraud, only letting eligible voters participate. It's a whole thing.
So you're not just checking a box, you're building the entire voting booth, the ballot box, all the security that goes around it, but you're doing it all with code. Sounds like you'd need to use all the other patterns we talked about for that. Access control, tokenization, maybe even registries for voter ID.
Exactly. It all ties together. A good voting system is like this whole orchestra of different design patterns all working in harmony. And actually, this connects really well to that next section on DACs and DAS, which often use these voting systems to function.
Okay, before we get into that, can we just take a second to clarify what all these acronyms actually mean? Because I gotta admit, DAO, DAC, DAS. It's a lot to keep straight.
Yeah, it can definitely sound like alphabet soup. Think of it this way. DAO, or Decentralized Autonomous Organization. That's the big umbrella term. It refers to any kind of organization that's run by a community and has its rules encoded on a blockchain. A lot of people consider Bitcoin a DAO, actually.
Okay, so Bitcoin a DAO. Got it. So then what's a DA?
So a DAO, or Decentralized Autonomous Corporation, takes that DAO concept and puts it into more of a traditional business structure. So picture a company, right? But there's no CEO, no board of directors. Decisions are made by the shareholders as a group, and any profits get distributed automatically based on rules that are already coded into the smart contract. It's kind of like when you hold stock in a company, you're entitled to a portion of the profits, right? But with a DA, everything's automated and totally transparent.
So a DAS is like a DAO, but with a business plan baked right in. Makes sense. Now DAS, this is where things get really futuristic, right? Decentralized Autonomous Society.
It does sound like something out of sci-fi.
Yeah.
And honestly, it kind of is. A DAS is all about exploring how these decentralized technologies could completely change the way our society works. Like, what if we could shift power away from those big centralized institutions and spread it out amongst everyone?
Okay, now we're talking. Give me an example. What would that look like in real life?
Well, imagine a world where we connect and collaborate through these decentralized platforms. So like social media, but owned by the users. Information can flow freely without censorship, and people have way more control over their data and their online identities. It could totally revolutionize communication governance, even the way we create and share value.
It's like taking the ideas behind blockchain and applying them to like the entire social contract. It's mind-blowing when you think about it. We went from these almost like bite-sized design patterns to imagining a whole new way to structure society.
It's a pretty wild ride, and that's exactly why this whole Ethereum Improvement Proposal process is so important. As we're exploring these big ideas and trying to push the boundaries of what's possible, we need a way to make sure the Ethereum itself can actually keep up.
Right. EIPs. That's like the whole community coming together to steer the ship, making sure Ethereum can navigate all of this new territory. So break it down for me. What exactly are EIPs and why do they matter so much if you really want to understand this space?
Think of EIPs as like the community's collective brain power, constantly working to improve and expand what Ethereum can do.
And the coolest part is that anyone can actually propose an EIP. It's all about putting your idea out there, explaining why it matters, how it could make Ethereum even better.
It's true.
So like if you had this awesome idea for a new feature, but instead of just pitching it to like a boardroom, you're trying to get the whole community on board.
Exactly. And if your EIP gets enough support, then it enters this whole life cycle of discussions and revisions and testing. It's super collaborative with developers and community members all weighing in, like poking holes in it, making sure it's as good as it can be.
That's awesome. So it's like a science fair and a peer review and maybe even a little bit of a popularity contest all rolled into one. Okay, so the chapter also mentions that there are different types of EIPs. Can you break those down for me?
Sure thing. So first you've got your standard track EIPs. These are the big ones, the ones that actually change how Ethereum works at its core. So think like how transactions get processed, how the network agrees on what's valid.
Yeah.
Like EIP 1559, that was a big one. That completely changed how transaction fees work on Ethereum.
Right, so standard track EIPs are like these major system upgrades. What about those other types?
Right, so then you've got informational EIPs. These are more like guidelines or best practices for developers.
Okay.
The ERC20 token standard we talked about, that's actually an informational EIP. It doesn't change the Ethereum code itself, but it provides these common rules that make sure all these different tokens can work together.
Right, like establishing a shared language that everyone can understand. Makes sense. Where's that last type again?
Oh yeah, those are the meta EIPs. Yeah, they sound kind of out there. Basically, these are all about improving the EIP process itself.
Oh, okay.
So for example, you might have a meta EIP that's focused on making EIPs easier to read and understand.
Meta.
Which honestly would be amazing.
Right. I'm all for that. Okay, so we've covered a ton of ground today. We talked about those foundational design patterns that help developers build better applications, the potential for DACs and DAS to like change the world as we know it, and that whole EIP process that lets the Ethereum community keep everything moving forward. But before we wrap things up, learner, we wanted to leave you with one last mind-blowing concept from the chapter, something that might just like totally change how you think about this technology. You ready for this?
Hit me.
Okay, so remember how we were saying that blockchain is just one way to build a decentralized ledger?
Yeah.
Well, this chapter goes beyond blockchain, literally. It talks about DAGs and something called the Tangle.
It's easy to get caught up in the blockchain hype, and forget that there are other ways to approach this whole distributed ledger thing. The Tangle is a really interesting example. It's what powers the Iota cryptocurrency.
Okay, so before we get into how it works, can you just back up for a second and remind us, why we might even need an alternative to blockchain? What are the problems we're trying to solve here?
Well, as blockchains get more popular, they can actually become victims of their own success. More transactions means more competition for block space, which can lead to those crazy high fees and slow confirmation times. Not ideal.
Yeah, I've totally been there, stuck waiting forever for a transaction to go through and then having to pay a fortune in fees on top of it. So how does Tangle fix this?
So instead of blocks, like we see in a blockchain, Tangle uses this structure called a directed acyclic graph, or DAG. Basically, transactions are all interconnected like a web. And here's the really cool part. There are no miners.
Whoa, no miners. Okay, now you've got my attention. But if there aren't any miners to validate transactions and keep everything running smoothly, how does anything get confirmed?
That's where the Tangle's design gets really clever. So if you want to make a transaction on the Tangle, you first have to validate 2 previous transactions.
Oh, so it's like you're paying it forward, but with validating transactions.
Exactly. And this ensures that every new transaction is linked to the entire history of the network, which makes it super secure.
Wow, okay, so we're venturing into some seriously advanced territory here, but I think that's a perfect place for us to leave it for today. We've gone from zero to Ethereum expert in just one deep dive. Learner, if you're ready to go even deeper, be sure to check out the source material for this episode, Advanced Topics and the Road Ahead. You'll find links in the show notes. And hey, if you had any aha moments during this deep dive, we want to hear about them. Hit us up on social media or shoot us an email. Until next time, stay curious and keep exploring the endless possibilities of this amazing technology.